Hey, sixth graders. I just wanted to make a quick video going over the model lesson for today and helping you understand the difference between overall shapes and data. So we have a couple different graphs over here. Some of them you recognize as dot plots with dots, line plots with X's, or we now know histograms, right? Which don't give us a full picture of our data. We can't understand each individual piece of data, but we do understand our data broken into categories or intervals, okay? So the first one I'm going to start with is symmetrical because I know in elementary school we talked a lot about symmetry and the fact that a butterfly is symmetrical or your face is symmetrical. And that just means if you were to split it down the middle, it's the same on both sides, right? Now, will there be subtle differences? Maybe. It doesn't have to be exactly the same, like exactly perfect. People always say that our faces aren't exactly the same on both sides. But for the most part, the idea is that there is some symmetry there. If we were to cut it down the middle or fold it over on itself, then it would match. Okay. So, because of that, I know that this picture is symmetrical. So, is this picture and this histogram right here is symmetrical. So if we look at it, if we look at the middle point of this data, right, where all of this data is, if we look at its middle point, we have about the same amount of data on each side. So remember that these graphs sit on number lines, which means that these are the lower numbers, like 0, 1, 2, 3, and these are the higher numbers the further right we get, like 20, 21, 22. Okay, so this is saying that we have about the same amount of data on the lower half of our graph as we do the upper half. It also means that we don't have any outliers or outsiders, right? Majority of the data is close together, okay? So the opposite, or not necessarily the opposite, because it doesn't necessarily have to be skewed left or skewed right, but the other choices that we do have are skewed left and skewed right. If you're looking at these pictures, you guys probably already decided which one you think is which, but oftentimes it's not what you think. Okay, so I'm actually going to tell you what skewed left is. And this graph is skewed left, which most people think is skewed right because all of the data looks like it's on the right side. But because all the data is on the right side or the higher side of the number line, like our larger numbers like 10, 15, 20, it means that we don't have a lot of data on our left side. Or you could think of it as like the left side of the data is kind of screwing our data up. So that's something that we can say with like if it's skewed left, which side of the data is screwing the data up, and we don't have a lot of data on the left, which means that's where any of our outliers or our outsiders are, right? They're over there on the left side, which means they're just messing up our data. They don't really fit with the rest of the data. So when all of your data is on the right side, or majority of your data is on the upper half of the numbers, it means you don't have that much data on the left side or the lower half. It's not symmetrical. We can't say we have the same amount on each side. Another way to remember it is if you were to draw a little skier at the very top, you ask yourself, how does the skier get down to the bottom? And the way he gets down to the bottom is by skiing to the left, okay? Because as you can see, we're getting less and less data points as we get to the left, right? So that's how we can get down to the bottom because by the time we get over here to the left, we have barely any data. So he's made it safely to the bottom, okay? That's where our outliers are. So that's skewed left. And then the opposite of that would be, let's see, I think I messed up my screen. All right, so the opposite of that is skewed right. Okay, so skewed right is where a majority of our data is on the right side. Okay, so we have a lot of our data on the lower half of the number line. Um, Numbers like 0, 1, 2, and it also depends on what your number line is going up by. Okay, but on the lower half, that's where majority of our data is, which means we don't have that much data on the right side, or that's where any of our outliers are. Okay. And you can ask yourself the same thing. If I have that little skier up here, he has to ski down to the right to get down safely. So I'm going to finish filling these in so we can see the difference. Okay. And the key with figuring out which way data is skewed is to ask yourself, where do I not have that much data? Where is majority of my data not there? And that's